You're on mute. Can't hear you.
Did you get any of that? Shall I start again?
Yeah, please start again.
My apologies. I don't know how I managed that first time in 18 months. My name is David Fraser, and this is the BESA webinar. And today we're doing all things net zero. I won't go through the bit I was going to start with, which is all the companies who passed their competence assessment standard. Congratulations to all of you. But we'll crack on, straight on with net zero. And I would like to welcome Simon Wyatt, who is a partner at Cundles, the global engineering consultancy, who's and also head of knowledge at CIBSE. So welcome, Simon.
Good afternoon, everyone. Lovely to be here.
I'm glad you managed to unmute, but there we are. We were talking off air before the start that your world has sort of caught fire, and there's a huge uptake in demand for your services at the moment.
Yeah, ESG has just got exponential growth, and especially around net zero carbon. But it's being driven by all areas of the market, but especially by the investment market, which seems to have embraced net zero carbon and ESG over the last year to a level we never expected them to.
All very positive. You're going to do a presentation. We'll come back and we'll cover some more of that ground shortly. But if you've got questions for Simon, you know where to put it in the questions box, and we'll carry on with some Q&A at the end. But Simon, over to you.
Yep, great, thank you. As indicated today, we're going to go through net zero carbon and the interrelationship with building services. Building services will play a vital role in the UK economy achieving its net zero carbon status. And it's fair to say there's going to be a significant amount of work going forward in order for us to achieve that. So today I'm going to be going through a brief introduction into the climate emergency and why there's the importance. Hopefully you should all be familiar with that and have a good understanding, but just to refresh, then we'll go through some of the drivers we're seeing across the industry and why it's really at the forefront of the industry at the moment. We'll go through what net zero carbon buildings are, the definitions. There's quite a lot of definitions come out over the last 2 years, but we're seeing more alignment of those definitions and more consistent approach to net zero carbon. And then we'll look at net zero carbon in operation, which as building services engineers think as being the important one and which we've been focused on probably for the last 2 decades. But there are some nuances and new ways of looking at things. And then finishing up around net zero carbon for embodied carbon, which has traditionally been generally a focus of structural engineers and architects, but we are now starting to look at the embodied carbon of building services. CIBSE released last year TM65, which is the methodology for calculating embodied carbon of building services, which I'll give a brief introduction to towards the end of the presentation. So just starting off with the climate emergency and re-stressing the urgency. So as you've probably all seen in the news over the last couple of years, there's a real need to act soon and act fast. At the moment, as a global community, we're on course for over 3 degrees of climate change. The world's governments agreed just over 5 years ago in Paris that we limit climate change to 2 degrees with an aspiration of 1.5 degrees. But we're significantly falling short of those targets and aspirations. And later this year in Glasgow, there will be COP26, which is where all the governments come back together, and they're supposed to be coming back with new pledges and new commitments to move us more towards the 1.5 degree target rather than the 3 degree trajectory one at the moment. And obviously, whilst we've been seeing for the last 5 years, even probably the last decade since Kyoto and the other climate agreements at Rio, we've obviously started to really see the impacts of climate change affecting us. We've seen 1 degree of warming already, and this has led to the extreme weather we're seeing all over the world. And even this last few weeks, we've obviously seen significant floods in Europe, in America. We had floods in London yesterday. The footage out of China is just startling. We've obviously seen forest fires in North America, the bushfires in Australia, and it's not just happening to developing nations, it's really starting to take hold globally and have significant impacts on people's lives, but also real estate businesses and properties. And the insurance market, investments markets respond to climate change, about how they can mitigate, but also look at adaptation to safeguard their investments. So over the last couple of years, we've really seen a ratcheting up of drivers for change. Just about a year and a half ago, Greta Thunberg sat outside the park, and then a year later, 6 million people protested globally. And that's really driven the agenda in the media. And before COVID, it was the #1 news headline. And since COVID, we've still been around #2 or 3. And it's been really linked back to a Build Back Better scenario and how we can actually look to recover from the pandemic and avoid the catastrophe coming through climate change. We've obviously seen governments around the world respond. The UK is actually the first to declare a climate emergency and set a legally binding target to be net zero carbon by 2050, which was amending the Climate Change Act, which was an 8% reduction. Now it has to go down to 0, which means every single industry needs to significant changes in order to meet these targets. And since that date, the over 408 local authorities in the UK have declared their own climate emergencies. And what's interesting is a lot of them have set targets significantly in advance of the 2050 target. Some councils 2030 and even some at 2025, which, to be honest, is probably too ambitious, and the scale of the challenge that they've signed themselves up to probably don't understand yet. And we're speaking to a lot of these councils to understand what they actually need to do to get their authority down to net zero carbon. We're also seeing drivers for change from occupiers. Lots of businesses are looking at their own carbon footprint, working out what their own fair share is, using science-based targets to set absolute reduction strategies. Most of the major developers in the UK have signed up to the World Green Building Commitment or the Better Building Partnership Commitment, which requires them to only deliver and operate net zero carbon buildings by 2030. And they're all starting to drive the net zero carbon agenda. And a lot of that has actually been fed from the investment market. So the investment market is really looking at ESG strategies and writing in climate change adaptation and mitigation strategies into their funding requirements. A lot of this is being driven by something called the Task Force for Climate Financial Disclosure, which was set up by the Bank of England and Carney and is now endorsed by banks and is going to become mandatory for pension funds this year in the UK. And we're expecting a lot of financial institutes to suit over the next couple of years. And this requires organisations to report their climate risk, but also the mitigation measures they're taking to reduce their own footprint. And there are a number of tools being developed so funds and property portfolios can start feeding into that to move towards net zero carbon. And one of those tools is called CREM, which has come out of the European Investment Community. And what this basically does is you can take the performance of a building or an asset, plot it against a Paris-proof climate trajectory, and see basically when the point of stranding occurs, which is basically where you stop being aligned with the amount of emissions that you're allowed to use and start emitting more than your fair share. When that happens, an asset value is expected to start to reduce, and you need to take retrofit refurbishment measures in order to keep below the Paris trajectory. So a lot of portfolio owners, people like Aviva, Legal & General, are looking at their entire portfolio and looking at how they can reduce the risk of stranding, so value properties depending on when they're going to strand and not be aligned with the climate science going forward. So that's kind of giving the market overview of where we sit. And next up, we're going to go through what that means in terms of net zero carbon buildings. So in the UK, European Union, buildings and the built environment is generally responsible for about 40%, and 11% of those are associated with the construction. And what's really important is to understand and terminologies. And over the last couple of years, we've we'll talk about things carbon neutral, net zero carbon, absolute zero carbon, and that hasn't used definition. But what has come out recently from the Whole Life Carbon Network, which is published on the LETI website, which hopes to align a lot of the definitions from UBC, the Better Building Partnership and other organisations who have defined net zero carbon after the years. And what they define net zero carbon to be different to carbon neutral is that carbon neutrality is basically where you calculate your carbon emissions and you buy offsets or removals to remove that amount of carbon. So any business, any product, any building can be carbon neutral by understanding its carbon footprint and then annually buying carbon offsets. So that's renewable projects, reforestation, forest protection to be carbon neutral. Where net zero carbon slightly differs, it requires you to make absolute reductions before you do offsets. So just doing offsets alone is not enough to be net zero carbon. Carbon requires you to reduce your carbon emissions in alignment with the Paris Agreement 1.5 degree scenario before you choose to move down to net zero carbon by removing the residual emissions, but you have to reduce your absolute emissions in line with the latest climate science to get a greater impact. And there's a few people starting to talk about absolute zero carbon, and one developer has actually set a target to be absolute 040, and that means there's no emissions associated with the operations of your business. To be honest, I've got no idea how you're going to build a building with no emissions associated with it, but that's the challenge they've got 20 years to solve.
Simon, can I just interrupt a second? Simon, could you just turn your camera off? The audio is a bit patchy at times, so could you just try with the camera off?
Oh, sorry.
The audio. Thanks.
Yep, sure. Okay, hopefully that's a bit better. In terms of frameworks, the main building framework that's used in the UK came from the UK Green Building Council. The Green Building Council's Advancing Net Zero Carbon Programme requires all new buildings to be net zero carbon in operation by 2030, and the existing buildings by 2050. There's a raft of guidance documents which are coming out for definitions and guiding how you actually start to achieve that. The framework is simple, it's fairly robust, it doesn't go into the detail of how you achieve it. I'll give you an overview, which is really focused on the first two activities here, which is reducing construction impact and then reducing operation energy. And what you need to do with both of those is achieve intensity targets, which I'll go through in a minute. And then once you've reduced the construction impacts, you can and once you've reduced your operation energy, you can provide that energy from renewable sources on site where possible, off site where not. And all of this has to be publicly disclosed, so there's clear transparency across the market, because there's a fair degree of greenwash out there at the moment, and having consistency is going to be really important for us to get down to the targets we need to achieve. In response to all of these frameworks, what we've done at Handle is we've put together what we call our 7 steps to net zero carbon, which go through the entire design process for new and existing buildings on how they go about achieving net zero carbon. So starting with passive design, then looking at energy reduction, removing fossil fuel use, because it's not credible to be claimed to be net zero carbon whilst burning fossil fuels on site, and then providing renewable energy whilst also looking at embodied and whole life carbon, with that transparency piece being the final piece in the jigsaw. If we start with operational energy, something which as building service engineers are probably more familiar with, we'll go through the definition. So the definition of a net zero carbon operational energy asset is one where no fossil use on site, which is really important. So that's removing gas boilers from existing buildings, but new buildings is fairly straightforward to design without a gas connection or any fossil fuel connection. All energy use needs to be minimalised, and I'll go through what that means in a minute, and we must meet local intensity targets. And again, this is a really important point, that we have to get down to a certain level of energy efficiency before we provide energy from renewables on site where possible, and off site where more difficult in urban environments. And those renewables should add additionality, so i.e. when you procure them, that they're adding additional supply to the national grid network. So what the targets are probably the key one here, and what we need to do is basically get to a point where the UK as a whole can provide 100% of its energy from renewable energy sources. So that means balancing our renewable supply to our demand. And at the moment, we generally produce about 20% of our energy from renewables, and we need to get that up significantly. So over the next decade, the government are building significant offshore wind projects and are probably going to double the supply of renewable energy. That obviously won't be able to provide everything now. So at the same time, we need significant reductions on the energy infrastructure. And if we take it evenly across all industries, it's about a 60% reduction. So the easiest way to think about a aligned net zero carbon strategy is to 60% off where we currently stand. There's an organisation called Letty who've done some analysis to work out whether those targets are achievable. They've modelled commercial offices, schools, residential projects, and what is good practice at the moment. If we apply all of the energy efficiency measures we can think of, how low could we get? And we kind of come to the same conclusion around that 60% reduction. So in terms of commercial offices, if we look at what current performance is, so this is current average performance and best practice performance, you can see achieving the UK GBC and Letty intensity targets means about 60% reduction from where we are now. So it's a significant challenge to the entire industry going forward. And what's important is the way we calculate these and assess these. So at design stage, we need to predict the energy consumption. And there's three tools for predicting this generally. So there's CIBSE TM54, which is an energy assessment calculation tool, which is really good for simple buildings or buildings with simple HVAC systems. We're looking at more heat-led buildings like residential developments. The Passive House Standard is really good at achieving performance in use, really focuses on a fabric-first approach and is appropriate for things like housing, potential swimming pools, potentially schools, which don't have complicated HVAC solutions, which are mostly heat-led solutions. Where we're looking at complicated HVAC solutions like commercial office buildings, then the Design Performance Standard, which has been launched by the Better Building Partnership and BRE, is probably the best standard for doing so, using advanced HVAC modelling software. What it's really important to understand is it's not EPCs. So partels and EPCs are really about energy. So they're looking at the individual efficiency of chillers, lighting, and saying how efficient is that piece of equipment, not how many hours are you running for that piece of equipment, or how many pieces of equipment do you have in the building, or how much air is that piece of equipment moving. It's purely saying how efficient is it at what it's doing. So it can't be used as a prediction of energy consumption. We need to use more sophisticated tools. So in terms of operating energy, some of the key things we need to look at, I'm not going to go through them all in detail. If you've got questions, we can come onto those later. But some of the main things we need to start to think about is thinking about sizing equipment to run at optimum efficiency for the majority of the year. So there's 8,760 hours in the year. When we design MEP plan, we're generally designing for the worst case scenario, which generally doesn't happen. And it also adds a safety margin on. So equipment is sized to work for a scenario which doesn't happen. The real peaks are generally considerably lower, and again, they're reached for significant small proportions of the year. Most plant chillers, boilers, fan coil unit, heat pumps generally operate mostly in the range of 20 to 30% of their peak. And what we need to be looking at is how efficient the equipment is working at those low ends, or having modular equipment so we can control more effectively the equipment we're installing. So it's really looking at how we control and use the different pieces of equipment for every hour of the year, and understand how we can size them more appropriately to their use. The other thing about the Design for Performance initiative is about verification and use. The design standard is there to help inform the strategy, help inform the design, controls, commissioning programs, but it's the verification which is important. We don't really care what the design calculation says. We want to know what the performance in use is, and therefore we need to go into buildings and watch them for the first year, 2 years, and really fine tune them to make sure that they're actually achieving the performance we predicted and there aren't strange things going on in the building. And that requires significant occupier engagement and working with tenant teams to understand how they're using those spaces and educating them on how to run equipment efficiently. The verifying use for commercial offices is coming out, and we've moved over to something called Neighbours UK. This is based on an Australian scheme called Neighbours, which basically is an energy efficiency rating for buildings in use, ranging from 1 to 6 stars, with 6-star basically being equivalent to net zero carbon. In Australia, it's taken them basically a decade to get to 5-star, and they've got their first few buildings around at 6-star. In the UK, the scheme was launched in October, and we're already trying to aim straight for the 5 and 6. It's going to be extremely challenging. And again, the real focus of this is performance in use using metered energy data. So there's no hiding performance of that asset. So what the Neighbours process basically involves is taking 12 months utility bills, taking the operating hours, the leased area, inputting them into a tool, and it would see a simple Neighbours rating or energy efficiency rating of 1 to 5 stars, and that should be reported on an annual basis with the star rating for the building, and that should be applied to all commercial developments. And it covers basically the landlord rating or performance. It doesn't cover the occupier performance. So it's looking at the lifts, the HVAC systems, the common area lighting, the hot water. What it doesn't look at is things like the solar power and the lighting ICT loads. Those are covered in zero carbon requirements. And if you go to things like the UK Green Building Council, they'll have targets both for the tenant and occupier. But when we're looking at Neighbours, we're looking at the stuff that the landlord can, which is the base building, and then also comparing that to the whole building performance. So just finish up on operation energy. What's been quite interesting with operation energy is people like the UK Green Building Council and REBA have set a step trajectory to achieving the Paris Proof 60% reduction. So they're basically set targets for 2020, 2025 and 2030, step trajectory, which seems quite a logical thing to do. So it's basically saying as we get better at building net zero carbon buildings, that target will ratchet up and down as we move towards net zero carbon. But you just need to be very careful. If you're a developer and you build a building to 2025 standard, that means it's only going to be net zero carbon for 5 years, and they're going to be reporting the performance of this building for its entire lifetime. So they're basically building a building that is net zero carbon, put it on the creme trajectory as we talked earlier, which will strand within the first 5 to 10 years of its operation. So they're going to have to do retrofit works to that building pretty soon after it's been completed. So what we need to do with new buildings is really try and push it down as far as we can. Ideally to the 2050 target, but if we can't achieve the 2050, it's really focusing on how far we can get it to comply with the Paris Agreement, ideally kind of for at least 20 years. And then at the end of that 20 years, we should only really be thinking about improvements to the HVAC equipment and the occupier equipment. What we don't want to do, and what no developer wants to do, is build a building and then have to reclad it after kind of 10 to 20 years. There's a physical cost to that, capital cost to that, and also a carbon cost in terms of embodied carbon. So really get a fabric first approach to design was really critical in order to safeguard buildings into the future. And it makes for an interesting discussion with a lot of project teams at the moment. So there's obviously been a reported cost uplift for net zero carbon. Most people are talking about a 5 to 10, 15% in cost increase for going net zero carbon. But the issue is if you take a whole life approach to cost, if you don't do that 10 to 15% increase now, you're going to have increased operating costs for the foreseeable future. And then again, when you reach that stranding point, you're going to have to do significant retrofit works, which are going to cost more than the original uplift. So where you're looking at a whole life cost analysis, it's much more cost effective to look at net zero carbon now than it is to try and do retrofit works to a new building in its just been built. Which is one of the challenges that most major investors are looking at the moment. on buildings. So the same targets apply both for new buildings and existing buildings. And what we're doing with a lot of existing stock is going in, reviewing the performance of that existing stock against our 7 steps, which we mentioned before, saying how they compare against the net zero carbon requirements compared to standard practice, and then making recommendations on retrofit and refurbishment works in order to move them to a net zero carbon pathway. And this can be done using detailed modeling as well. So taking energy data, performance building, putting that into a simulation to build a digital twin, and then measuring impacts of individual interventions. So replacing heat pumps, improvements to the fabric, going to natural ventilation, behavior change. All of those things will add up to give a performance moving towards the net zero carbon target. But obviously with existing buildings, it's not as simple as taking back possession and doing all those works simultaneously. That needs to be planned into the building and operation of the building so that there is a net zero carbon pathway for the asset based on leasing arrangements, plant replacement arrangements, end of life of plant, and that all needs to be factored in. Some of those pathways may be a decade, others might be much shorter timescales. So it's really understanding for every building what needs to be done to move it towards net zero carbon. And pretty much every building you see in the country, every street you walk down, by 2050, every single one of those buildings will need to be retrofitted to be net zero carbon. So the scale of the challenge is significant going forward. So that brings us on to embodied carbon. So we've obviously gone through the operational side. Embodied carbon is generally not overly considered by building services. It's more of a consideration for structurals and architecture, as I said, but it does increase in importance as we obviously meet our energy intensity targets and decarbonize the grid. The embodied carbon of building the building becomes more important. And most buildings that are being built now will probably have 60 to 70% of their carbon emissions associated with the embodied carbon and the materials of its construction, and most of that on practical completion rather than in use. And when we talk about embodied carbon, we're generally talking about cradle to grave. So you're talking about extraction of materials, processing, transportation to site, the site activity, which is all known as the upfront embodied carbon, and this can be fairly calculated now and reported at practical completion. The London plan now requires you to do it for all referable schemes, so you have to calculate the embodied carbon and report it on practical completion. The story doesn't end there. Every year you're going to use carbon for repair, maintenance, refurbishment, and all of that needs to be reported on an annual basis, and again offset if need be. And at the end of a life, when a building is demolished, there's carbon associated with its demolition and potential reuse in the circular economy. And designers are now starting to think how they can disassemble and reuse equipment. And in terms of building services, we really need to think about how we can reuse equipment at the end of the life, how we can repurpose it so that we can reduce its overall embodied carbon. But the main focus, as I said, is this upfront embodied carbon, because that's what we can affect now, and that's where the climate emergency is at the moment. The methodology which we use to assess whole life carbon and embodied carbon is the RICS whole life carbon methodology, which again looks at this upfront, which is known as A1 to A5. Then you have the in-use stage, which is known as B1 to B7, and then end of life, which is known as C1 to C4, with a requirement for looking at reuse, recycling, and refurbishment, which is known as the D modules. In terms of today, what we're going to be looking at really using on that upfront embodied carbon, which forms part of steps to net zero carbon, and the definition of net zero carbon upfront asset is one where the sum of all the greenhouse gas emissions meet local intensity targets with any additional offset to zero. So what we're basically saying here is that you have to hit the energy carbon intensity target and then offset down to zero. So it's not a case of getting as close to the target as you can and then offsetting the difference. It's getting to the target, then offsetting. If you don't meet the target, you can't claim to be net zero carbon. You can claim to be carbon neutral, as we discussed earlier, but you can't claim to be net zero carbon because you're not aligned with the Paris Agreement targets. And what's interesting with targets, we discussed the LETI targets earlier, The LETI targets are very ambitious. They're what we need to get to. So they've got 2020 targets of around about 600 commercial developments and 350 kilograms for their 2030 targets. The current market best practice for traditional concrete and steel buildings is generally around about 700 to 800. If you go timber, you might get down to that 600. But the only way to get anywhere near the 350 is to use significant retrofit and refurbishment. So those targets are aspirational. They're not achievable with the current market at the moment. And we need to look at how we can decarbonize the supply chain as we go forward. LETI and the Reburn Whole Life Carbon Network recently published new banding for embodied carbon, both upfront and whole life. And again, it's a bit like an EPC, so you can actually get a scoring for your embodied carbon associated development with the best practice, as I said, achieving probably this CD border at the moment in terms of commercial high-rise buildings. Lower-rise residential buildings are generally achieving probably around this A+ rating potentially. Using industry software like one-click LCA, eTool, Ecolabs. There are a number of systems, but what's important is to try and use the same tools to get consistency, because they will give slightly different results going forward. And generally, where the focus has been for the last decade has really been on the structures. You can see here that for most buildings, 50% of the embodied carbon is generally associated with the frame, upper floors and substructure. So that's really where the focus is. And most structural engineers now are able to report at fairly early stages what their predicted embodied carbon is. Building services only generally equates for between 10 to 15% of the embodied carbon of most buildings, and hasn't really been accurately calculated before. Most of the tools I went through earlier just allow a factor for embodied carbon and building services, either on a per square meter rating, per cost rating, or just a percentage of the building. But what we need to start looking at is actually calculating the performance of building services, so we can compare systems and also compare manufacturers, so we can actually start influencing that 13%. And last year, CIBSE published 65 embodied carbon of building services, which is the first ever standard globally for embodied carbon of building services. And as you can see from the diagram on the right, 92% of the carbon emissions associated with building services actually in the materials themselves, is not in the construction or end of life. It's in the actual construction of those materials. What we need to do is start understanding the materials we're using and how we're putting them together. And the main reason building services has lagged behind some of the other sectors is the complexity of our supply chain. If you think about a structural beam, it's a fairly simple supply chain. It's basically ore that's extracted from the ground, is processed in an ironworks, and then transported to site. So understanding the embodied carbon of it is fairly simple. Whereas if you think about a air handling unit, for example, that has hundreds of components. Those components are all manufactured in different plants. They're transported around the world to be assembled and then transported to site. So we need to take into account the transportation of those components, where they're built, and also how they're used. For example, if you've got two identical HUs, one that's been built in, say, Scandinavia and one that's been built in China, they're going to have hugely different carbon footprints, even though they've got exactly the same weight of metal and materials in them, because of the where the factory is, the intensity of the electricity that they've used to generate the components, and also the transportation of components. Sometimes an AHU or chiller or boiler could potentially have dozens, if not hundreds of components, which have been assembled in factories all over the world and then transported together. So what we need to start to do and push the supply chain to do is start to account for their supply chain, understand the carbon footprint of all the components that go into their products, and start reporting this. Blockchain will hopefully enable some of this to go forward, but it's going to be quite an onerous and difficult procedure. So most building services, what we need to take into account is the extraction of the material, transportation to factories, manufacturing and transportation to site. We also need to think about the disposal of those materials and potential reuse, and on your basis, repair, maintenance and refurbishment. They all need to be considered, calculated and understood. And what's really important with building services is really starting to understand refrigerant leakage. We probably, as an industry, underestimated the amount of leakage, and refrigerant generally is over 1,000 to 2,000 times more potable greenhouse gas compared to CO2. So even small leakages have significant impacts. And what we've done a number of installations recently is that the refrigerant leakage has actually got a higher greenhouse gas potential than the actual installed of the materials of the building services. So we really need to get a handle on how much refrigerant leakage we're getting from systems. CIBSE TM65 goes through some methodologies on calculating this, but we really need to start reviewing how we get that data and report it going forward. So the process really is fairly simple. What the building services are proposing to look at mostly is something called an EPD, which is basically an energy performance declaration from a manufacturer. So that is basically a certificate from a manufacturer saying what is the embodied carbon of their product. There are strict rules in setting up EPDs, and it requires a percentage of the supply chain to be accurately calculated and submitted. The idea is that every product will have EPDs, so boilers, chillers, that will all come with EPD certificates, which can be combined to work out the overall building services emissions. Where there aren't EPDs for the products, CIBSE are looking to build a database. Would like any support from you and your members to provide data on existing products, so we can look for representative products to use in an EPD library. And where there isn't information in terms of EPD libraries, there will be rules of thumbs on how to calculate standard emissions for various types of equipment based on generic information. But the idea is we move more towards the EPDs as we move forward. At the moment, I'd say probably less than 5% of the building services and HVAC manufacturers are able to provide EPDs, but there are more and more clients, consultants and contractors asking for this information, and it would be a prerequisite for most people probably within 5 years that they only are able to buy products which have EPD certificates. So that was kind of a quick net zero carbon in construction and operation. I've left hopefully enough time now to go through some questions.
Hopefully you can hear me this time. Should we try with the camera briefly on and see if it's any better this time around?
Yeah, sure. I'll stop sharing the screen as well, reduce the bandwidth.
Yeah, great, okay. Well, thank you very much. I feel like I've done sort of the first year of a degree course very rapidly run through. It's such a huge area to cover, but thank you very much for doing that. So let's kick off with some questions. Don't forget, if you have any questions, please put them into the questions box and we'll get round to them. When we're talking about operational energy targets, we use kilowatts per hour. Why isn't it kilograms of CO2 when we're talking about net zero carbon?
That's a good question, and it is an important. There's been quite a lot of debate in the industry over the last couple of years on whether energy should be talked about in kilograms of CO2 or, and the reason for it is really to do with the speed of grid decarbonisation in the UK. If you look actually projecting that would be at zero carbon within the next decade, which means that there's no incentive to do energy reduction. But the issue is that we can't do a energy intensity on the grid of zero unless we to get energy reduction. It comes back to what I was showing you earlier. We need to increase capacity whilst reducing demand in order for us to provide 100% of the UK energy from renewable. That means everyone must have an equitable, fair share of energy, and that's why the energy intensity targets are really important. But when you plug that into whole life carbon calculations in terms of kilograms of CO2, the energy is less important. So what we're trying to do is keep energy at the forefront of people's minds and energy efficiency rather than just move on to carbon.
Great, thank you. So what's the best thing we can do to reduce embodied carbon of building services?
Yeah, like I said earlier, building services is probably at least a decade behind structures in terms of understanding embodied carbon. So the first step is really trying to get the EPDs and understanding what's going on in the supply chain. Measuring what we've got, can we actually start to look at reductions? So all manufacturers need to really start to think about where they're procuring all their products from, what their energy consumption is in the production, and then assigning that to the individual products. Then products can be compared against each other, and then we can start to drive down efficiencies. As I showed you earlier, the best buildings at the moment are generally achieving 600, 700 kilograms of CO2. We need to be down at 350. You're not going to get that through efficient design. We're only going to get that with significant supply chain engagement. And the first step for the supply chain is understanding what the current emissions are and what is possible. And again, most of the major developers and clients are really wanting to engage with the supply chain on how they do this. So they're looking for innovative partners who can basically come up with solutions which can drive that down. Step is understanding what emissions are, producing EPDs so that we can really start to drive those down.
Sure. Yet some suppliers are claiming that their products are carbon neutral. So how is that possible?
Yeah, this is an issue all across the industry at the moment. So a lot of organizations are working out their carbon footprint, and then they're offsetting all, as I said, and that makes them a carbon neutral organization, and they're applying that to their products. So they're basically, you can have cement manufacturers who are producing cement, but then claim they're offsetting their emissions with reforestation projects, and they're claiming that the entire business is net zero carbon, so their products are net zero carbon. That is not taken into account in EPDs. EPDs does not allow any offsetting. It must be pure reductions. So if you see anything which is written as net zero carbon as a product, it's not real. Every product at the moment has a carbon footprint. And as I showed you earlier, some developers are looking to move to zero carbon where products don't have a footprint, but there's no clear way of doing that at the moment. Like everything you manufacture has transportation, it has extraction process. All of these things will be derived from some form of fossil fuel. So don't be in a footprint. Once you understand your footprint, we can start reducing it, but don't just jump to shortcuts, which is offsetting. Offsettings do have their place, but the key thing we need to do is get reductions going forward.
One of an interesting point that somebody's raised about the current cladding scandal and and actually Grenfell, just listening to that, the relationship between freeholder, leaseholder, tenant, client, developer, funder. Does that need major reform? Because at the moment, what we're hearing from Grenfell is everybody else thought everybody else was doing it, and so many people who are involved in these projects have no long-term skin in the game. They're not. The energy cost falls upon the occupier by and large. How do we address that issue? And do you see the major change coming that way?
Yeah, it's probably the biggest elephant in the room. It's really difficult. I'm working with lots of. It works both ways. So as you say, a lot of the energy falls down to the tenant, but it also falls to the landlords. So most of the landlords and developers who've signed up to the net zero carbon commitments have actually signed up to achieve net zero carbon across all their scopes. And their scope 1 and 2 emissions are their own electricity and gas use, but their scope 3 emissions include their occupiers' energy usage. So if you're legal and general and you have a building, the energy they use in that building is your scope 3 emissions, same as if they've got light manufacturing. So they need to influence the behavior of their tenants. So they really need an engagement piece. And I see probably the biggest challenge and opportunity at the moment as occupier engagement and behavior change. So working with occupiers to reduce their carbon footprint, to educate them on what they do, setting them individual pathways, because no one can achieve these things on their own. It needs to be done holistically, and we need to be looking at how we do that. So what we're probably going to see in the next few years is a lot more businesses thinking about net zero carbon in terms of acquisitions and where they move to in terms of the premises, but also landlords thinking about the kind of tenants they want, and also moving potentially towards more green lease clauses, so requirements on occupiers to achieve certain standards. So it's going to go both ways. You're going to get demand for net zero carbon from occupiers, but you're going to get landlords requiring occupiers to actually achieve certain standards.
So do you think current policies are enough to deliver decarbonisation targets?
No, in short, it's interesting. So there's two major drivers. You've got regulation and the government drivers, which is pushing the bottom of the market. But then you've also got market forces, which are driving the top of the market. The top of the market is moving there towards net zero carbon, and they're doing so for commercial reasons. The investment community accessing funds and finance is becoming a prerequisite for ESG requirements. So you won't be able to access finance. A lot of large portfolio owners are now using, as part of technical due diligence, review the asset performance, and they're using that to offload poor performing assets they know they can't move towards net zero carbon. So they're going forward. But we also need more stringent regulation, which is starting to emerge. The main thing is probably regulation of embodied carbon. So there's a movement at the moment. There's for something called Part F, Part Z of the building regulations, which would be embodied carbon. Whether the building regulations is the right place for that is simple, but I think most of the industry support the regulation of embodied carbon. The other thing is BESA currently looking at mandatory performance of buildings. So this will be a requirement for all buildings to disclose their operational energy, a target that they have to achieve. And this will be a bit like the DECs at the moment. You report where your performance is, and there'll be a lot below the line. You'll be fined, basically, because the government have a legally binding target to hit 2050. So as we move towards 2050, we're going to get more and more nervous and have more requirements to ratchet up on the industry. So what you'll probably have is a league table of buildings, and there are basically levels of fines or penalties. Those penalties in reality for most businesses will be quite low, but what will drive a lot of the improvement will be reputation. No developer or landlord in the current climate will want their buildings and assets to be at the bottom of that league table. They all want to be up near the top so they can demonstrate their ESG credentials to their clients and their staff, because ESG is really driving up people's agenda.
You referenced passive house there. Do you think that will replace the SAP calculations?
I was having some good discussions on that yesterday, actually. No, it won't replace SAP. SAP is embedded into the building regulations and is fit for purpose in terms of looking at compliance with building regulations. It's not fit for purpose for predicting operational energy. Passive house is proven to predict performance and performance in use. It looks at it in a much more sophisticated way, looking at detailing and construction, buildability, and how things are actually built on site. So passive house is great, and I think a lot of local authorities will probably start putting passive house into planning. A lot of my clients as developers are starting to put passive house as their requirement for residential. So I mean, we're seeing a huge uptake. Like you want to get building passive house certified, you'll struggle to find a certifier this year. So it's ramping up significantly, but it won't go into the building regulations. It may go into the planning.
Thank you. So still talking about councils, I guess. Are you seeing any councils who are taking on neighbours, or is it more private developers and larger companies?
Neighbours has really been driven by the developers, so it's been driven heavily from the BESA building partnership. All the major developers and landlords have generally signed up to it and are running test pilots. A number of local authorities are looking at it, but again, it's really aimed at larger buildings and complex HVAC systems. Most councils are looking at net zero carbon and trying to put their strategies together, but for a lot of local authority buildings, CIPSI TM 65 is more than sufficient for those analyses, and there are other routes to designing for net zero carbon. But most local authorities have the biggest issue most local authorities have got is they have their own estates which they need to decarbonise, which is a significant challenge. But most of them have set their net zero carbon aspirations for the entire borough or area, and that requires all the private buildings within their demise area to be decarbonised as well, including all domestic buildings as well. So they've got a huge challenge, which some of them are only just starting to get their head around.
Other than heat pumps and PV, what near future technologies look to be most viable for reducing carbon for existing buildings and services?
It's an interesting one, and the thing with net zero carbon, which we've found, is there is no silver bullet. There is no technology coming over the hill to save us. The main focus of net zero carbon is good design and good installation. Like Australia have basically been able to halve, I think 70% reduction in their energy consumption over a decade in commercial buildings. They haven't done that by installing better equipment. They've done that by controlling and commissioning and designing their buildings better. They still use exactly the same equipment they were using 10 years ago. They're just using it more efficiently. So again, it comes down to those fabric first approaches, making sure that the loads are significantly reduced, sizing equipment so it's running at its optimum for the majority of the year, and then looking at supplying that energy efficiency. So even things like truss heating, how much pipe work have you got outside the building compared to inside the building, that adds up. Like in the UK, we generally don't predict operational energy, and just miscellaneous energy consumption associated with landlord systems can be up to 20–30% of the energy consumption of a building. We generally just forget about in the UK. So it's really thinking about all those small elemental things to move us towards optimum performance. There are technologies which are coming online. Obviously, everyone's moving to heat pumps. The issue with heat pumps is obviously domestic hot water and how we can do that efficiently. So do we use different technologies? Do we use CO2 heat pumps, or do we use staged heat pumps? That's a bit of a debate and discussion. Hydrogen always gets thrown in the mix, but there is no ready supply of hydrogen. We could be waiting a long time for a hydrogen economy in the future. It has a potential to do it, but so does nuclear fusion. But we're a long way from both of those as being mass rolled out. So heat pumps are generally the best option we have at the moment. But what we're doing on a number of buildings is if we can get the heating to passive house standards, there's almost no requirement for heating. Like if you can remove all space heating, the only heating load you have is an air heating load. So you can go for a heat pump in your air with your attached to your AHU, and then just have a small amount of reheat, which is electric. It's obviously more expensive, but if you have no load or nearly no load, then the cost is minimal and the embodied carbon is minimal.
So actually, that's a very interesting point as well. With the extreme weather events we've been seeing across the world in the last couple of weeks, and I think I saw a report saying that in London you can expect some summers with 40°C temperatures. Doesn't that extend the range in which building services designers and equipment have to operate? And how are we going to cope with that change? Because we're actually exceeding the climate change models at the moment. How do you design to that?
Yeah, no, it's a really good question. Yeah, and all the modelling that's been done has underestimated climate change, and most of the design criteria we use is out of date, and most of it is based on historic data. There is some that is based on future weather predictions, but those are based on out-of-date predictions. Like CIBSE have just got funding to look at the future weather files, but at the moment the weather files that most people use in their design of overheating and frequency analysis are massive underestimates of where we're going to be. It's a really difficult question, and we need to be taking that into consideration, but it's understanding when those occur and modularization. Like if you're building a building, you want the structure and the infrastructure to be designed to be operating in 2100, whereas building services we know get replaced in 20–25 years. So we need to design it for the appropriate life. So we need to look at 2050 conditions and have solutions to add or bolt on solutions if it gets warmer in the future for different scenarios. So we need to look at risk analysis, and we wrote for the BCO the climate risk analysis design guidance for commercial offices. And basically what you need to do is look at each design parameter, understand the risk of climate change, and then look at the different scenarios and cost what the that are required to achieve that. That could be leaving space for additional chiller modules, or it could be installing things from day one. But what we're probably going to have to get used to is slightly warmer conditions and climates. So in Switzerland, for example, they don't have a fixed temperature, they have a delta. So basically, they say you have to be within a delta of the ambient temperature. And as CIBSE's move to adaptive thermal comfort, we'll probably see adaptive thermal comfort standards ratchet up and be more accepted for higher temperatures as we get used to those higher temperatures. The problem we've had in the last couple of weeks in terms of temperature hasn't been the temperatures been particularly high. It's the difference from the previous couple of weeks. It's been cold and fairly mild, and then it spiked fairly warm, which caused people discomfort. If it's warmer for significant periods of time, then we'll just have to start to get used to it. But the problem is we're getting more air conditioning. The air conditioning issue is probably one of the biggest concerns globally.
What impact's COVID going to have on how we design and operate buildings? There's a newfound, or should I say, newfound respect for ventilation, particularly, and a lot of advice coming out. You must ventilate buildings to a greater extent properly is probably the word we're looking for, which you haven't done in the past. How is that going to impact energy? Because there is also a feeling with sort of Grenfell and other projects that actually in the bid to get energy efficiency, we forgot safety. Is that going to, so is COVID going to have the same impact, do you think, on energy efficient design building services?
It has the potential. I think you summed up very well with saying that we need to design ventilation properly. I think there's been a lot of work from CIBSE. CIBSE have been publishing regular updates and feeding into the SAGE investigations on ventilation and clear guidance in terms of the amounts of ventilation we need and how to do that. And there's more guidance coming out for winter time when obviously energy efficiency will become more important with regards to heating. Good ventilation is really important, but the current standards we have generally give us those kind of good levels, like looking at kind of 12 to 16 litres a second per person is good levels of ventilation. Even distribution of that ventilation is really the key. It's more about dilution than about bolt-ons and add-ons. And what we saw at the beginning of the pandemic was lots of people going out and buying additional filtration for their AHUs. And that was just added resistance. So yes, the air that was coming in was probably cleaner, but their ventilation rates were significantly down. Using the appropriate filtration where required, and the issue and the main sources of the virus are from people inside the buildings, not the air coming into the buildings. So we need to be diluting that air and moving it out as quick as possible, and doing that in a streamlined way. Again, at the beginning of the pandemic, a lot of buildings were leaving ventilation on 24 hours a day. I think that's stopped now, and most people are managing their ventilation much more consistently. But what we do recommend is people start looking at demand-driven control. So instead of just supplying equal amounts of ventilation everywhere in a building, installing sensors, probably on CO2, that move air around where it's required. So if we do have occupancy density, we just move the air around sensibly. Like most buildings have more than enough ventilation. It's just not being able to move it to where it's needed. If we install controls and dampers that enable us to move the air around more efficiently and enable us to supply higher rates in certain areas, then we won't get an energy penalty because we're still moving the same amount of air overall. And also moving to mixed mode ventilation where possible. So where the air quality is good enough and the acoustic issues aren't a problem, it's looking to open windows for significant periods of the year. In winter, we should always have mechanical ventilation with heat recovery, but for probably 50–60% of the year, there's no reason why in the UK we can't just have open windows and ventilation as long as the depth of the buildings allow for it. We still need the mechanical systems for peak winter and summer, but for the majority of the year, we can turn them off.
Great. Well, I can't believe our time's up. That's been a fantastic run through. I've got one final question. But before I come to that, the slides and a recording will be available on our website afterwards. There's been quite a few requests for that. Simon, if you're a contractor and you're not really on the net zero path yet, where do you start? What should you do? How do you engage?
As a contractor, well, anyone, I think the first point of people is understanding your footprint. It's a bit like the EBD. You need to understand where your emissions are coming from, and then you can start understanding where to focus. I think most people don't have a clue of their footprint. And again, you should be doing it holistically, so as an organization level, and then your property forming part of that. So where we work with a lot of clients, we'll look at their corporate carbon footprint, and then their real estate, new developments and existing assets will feed into that to get a kind of footprint. And then it's about making those reductions. For most existing buildings, it's fairly easy to go in and make kind of 10 to 20% reduction just by reconfiguring. There's probably quick wins to take it down another 10 to 20%. So even without spending significant amounts of money on existing buildings, we probably can see 30 to 40% reductions. It's maintaining those reductions is extremely difficult.
Well, thank you very much, Simon. That's a fantastic run through a very complex topic, and your explanations have helped a great deal. We haven't been able to answer all the questions that have been posed. There's loads and loads of them. So we'll take those to our LinkedIn page and we'll get some answers up to those in either today or tomorrow. So thank you for asking questions. Thank you, Simon, for an excellent presentation. And I'm going to ask you, will you come back and cover some more for us at a point in the future?
Certainly. It was a pleasure. Thank you.
That's fantastic. Thank you very much. So that's it for today. Just a reminder that 3rd and 4th of November is the BESA National Conference. If you like what you heard today, there'll be plenty more of this kind of topic being dealt with at our conference. So sign up now. And on that note, thank you to everybody. And thank you again to Simon, and have a good afternoon. Thank you.